For reasons of my own, I have quite an unhealthy interest in these things. I mean, yes, it's bellows. So when you think about bellows, you're probably thinking of something like, I don't know, a blacksmith's forge maybe lighting your fire, maybe protecting the carriageway of a moving tool or something like that. But bellows, I think, are most underrated and actually have a lot more uses. But it does present a problem in 3D printing them because, for instance, you need the material to be flexible because the bellows has got to do that. Now, this particular one is printed from this material, which is TPC, or thermoplastic copolymer, and it has a shore hardness of 30. Now, shore hardness is kind of a way of measuring the flexibility of it. So 30 is a little bit stiffer than something like an ordinary rubber band. This one is printed out of TPU, which is thermoplastic urethane, and it's kind of becoming a bog standard, de facto standard material, and that has a shore hardness, this particular one, of 95. And that's kind of the same hardness you'd find in a supermarket shopping trolley. So although this acts like a bellows, it's pretty stiff to be able to get it to bellows. You need to put a lot of force in there. Of course, I could make it thinner, maybe using something like vase mode, but what happens then is you just get holes in it, and it doesn't act as a bellows, it pops. So it is, bellows aside, some interesting problems to do with 3D printing that I think I might have worked out some solutions to. Because that ability to get that to fold nicely, I don't think works well if you're using one material. For example, if I push this bellows down, see what happens there? It kinks up and it kind of pushes it out, putting a limit on how successful those bellows are going to be when I actually use them. So I thought it might be useful if we did this out of two materials. So here we can put ribs where it needs to be stiff, and here we can put flexible material where it needs to bend. And my two materials of choice were PLA, of course, and TPU, of course. What we want to be able to do is print these hinges, in inverted commas, in TPU, and these ribs in PLA. That way we'll get a stiff section, and we'll get the bendable section where we need the bendable section to be. So to do that, we have two challenges. One is to print a large flat area of TPU, and two is to print the PLA on the top of it in such a way that it sticks. Now, TPU actually is quite problematic to be able to print. It's not the printing itself, it's the adhesion to the bed. This is a PEI sheet, and PEI sheets, when they first come, are brilliant actually. I mean, before these things, what you had to do was, well, use loads of glue and bits of tape and all kinds of things to get it to stick to the sheet. When these things arrived, for about 6 months or so, they're absolutely brilliant. Anything you print on them sticks to the sheet and it releases really easily. But that coating of whatever it is on there actually wears out, and then things begin not to stick or to stick too well. When they're not sticking anymore, the advice is to use something like this. It's kind of a Pritt stick. This one's actually a glue stick meant for 3D printers. It's JT16. But you apply some glue stick and that helps your print stay on the bed. It does leave an issue. And the issue is you get all this glue stick gunk on here that you kind of got to clean off every now and then and restart it. And it does get pretty gunky and pretty messy. The other issue is that TPU in thin layers, large thin layers, sticks to this like glue to a blanket. People have been tearing off the coating on the PEI sheet, trying to remove their TPU prints. I mean, some people say they don't have that issue. I've tried it, I have that issue. So I looked around for something that would work, and people often recommend putting a layer of glue stick on and then removing the glue stick with Windoline. Actually, it's the vinegar in the Windoline that does it, because glue stick will dissolve in vinegar, it'll dissolve in IPA, if you really scrub at it, water obviously. But then you've got the issue of it being a large flat sheet, and that vinegar can't actually penetrate it. So what we need is something that will put a coating on there that the TPU will stick to when it's being printed and yet lift off really easily after it's printed. Now I want to introduce you to this stuff. This stuff I mean, it's amazing how well that works. And what it is extra firm hold hairspray. A couple of coats of this, printed TPU, and the thing cracks off really beautifully. So you've got your PI sheet and spray your hairspray. Give it a good coating, leave it to dry. So here's my printed flat TPU. You see it's a large sheet covering the whole bed. Printed in TPU on the PI sheet on the hairspray covering. And once it comes off, ta-da! Oh, that was just awesome! Hairspray, I mean, who'd have thought it? Now, it's not my idea. I came across this in the forums, actually, and it was the first time I came across it, so I thought, well, let's share this in case anybody else hasn't heard about it. Now, I paid £2.19 for this tin of hairspray, and I think that's about £1.50 for that stick of glue. So the hairspray is actually probably going to end up being cheaper. Of course, what I needed to do then was print the PLA ribs on top of the TPU hinges, and it's renowned that PLA doesn't stick to TPU. But in fact it does. It does if you approach it a slightly different way. So here we've got PLA on TPU, and that's the hardest way to do it. Once you've printed the TPU, you change your PLA setting for the first layer, so the extrusion temperature is about 260 instead of the normal 220. It works when you have a large flat area. If it was a thin area, then there's not enough mechanical bond to grip it. But a large flat area where the first layer is printed slightly higher in temperature makes it stick beautifully. Now, if you do it the other way round, so you've got TPU onto PLA, you don't need to do that because a TPU prints at 270, and so it will melt a little bit into the PLA, creating a firm mechanical bond. But again, the bond is only good if the surface area of the bond is large. If you've got a thin line, it is impossible to bond. If you do this with raised temperatures and a large surface area, it bonds really quite well. I want these multi-material sheets to make myself sets of bellows for another use, but I don't think that really matters. I think these will be better than these because of the stiffness and flexibility in the right places. However, that's just for the bellows project. In terms of handling TPU, especially when mixing it with another material, I thought that this would be useful to people. So if you haven't heard about this stuff, I thought it might be interesting to hear about it. I hope you enjoyed the video. Thank you very much for watching, and if this bellows project does work out, of course you'll see the bellows project. Anyway, please do remember to like and subscribe.